Hi everyone, in this video we're going to cover the following topics. If they are familiar to you, please skip the video to the questions, answer them, put your answer in the comment section below. If they are not, just join my class. Hi ladies and gentlemen, welcome back to my class. In this video we're going to talk about Lewis structure, or as we call it, Lewis electron-dot structure. To draw the Lewis structure for single atoms, it's very easy. Just draw the symbol for the atom, and around that symbol we have to draw the valence electrons as dots. And in case you forgot what do we mean by valence electrons and how we determine their number, I'm going to keep a link in the description below for a video titled as Octet Rule. It's better to have a look on that video to understand what do we mean by valence electrons and how to determine their number according to the group. For example, since sodium belongs to group 1, its Lewis structure is going to be like this. Beryllium belongs to group 2, its Lewis structure is going to be like this. And as you noticed, we don't begin to pair electrons on one side until all four sides have one dot. So the Lewis structure for boron, which belongs to group 13, is going to be like this. And carbon in group 14 is going to be like this, with one dot on each side. And after having one dot on each side, we can start pairing electrons now. Like nitrogen in group 15 is going to have a Lewis structure like this. Oxygen in group 16 with 6 dots. Fluorine in group 17 with 7 dots, and neon in group 18 with 8 dots. Don't forget that helium, it's an exception. It's in group 18, but it has only 2 valence electrons. Let's talk about simple molecules like chlorine molecule. It's made up of 2 chlorine atoms. Chlorine is in group 17, so the chlorine atom is going to be represented like this with 7 dots around it. Chlorine, to have a stable octet, each atom should contribute with 1 electron in a shared pair of electrons. Then each atom is going to have 8 valence electrons to satisfy the octet rule. This pair of electrons, it's called unshared pair or lone pair, while this pair of electrons, which is shared between the 2 atoms, it's called shared pair, and usually it's represented by a long dash like this. Then we place the unshared dots like this. In case of a hydrogen molecule, hydrogen has only 1 valence electron, so the Lewis structure of hydrogen is going to be like this. And since hydrogen doesn't satisfy octet rule, it satisfies duet rule. Each atom should contribute with 1 electron in a shared pair of electrons, and then we are going to draw it like this. And now is the important part, since we're going to talk about how to draw Lewis structures for many atoms. And to do this, you have to follow the following steps properly. And the first step is to count the total number of valence electrons, and this is possible only after drawing the Lewis structure for all the atoms in our compound. And by the way, after listing all the steps, I'm going to keep them displayed while I'm practicing applying them. The second step is to arrange the atoms. Usually when we do this, we have to place the carbons at the center. If we don't have carbon atoms, then we have to place the elements with the lowest electronegativity at the center. If you find it difficult to know which element is the lowest electronegative, you can find the link in the description below for a video talking about trends in the periodic table, which will teach you the variation in electronegativity as we go down the group and as we go across the period in the periodic table. And since hydrogens and halogens, which are elements of group 17, can do only 1 covalent bond, so we have to place them at the ends of our structure. The third step is to distribute the dots, which are the valence electrons that we counted in the first step. We have to make sure that atoms are surrounded by 8 dots to satisfy the octet rule, with a few exceptions like hydrogens, beryllium and boron. I will talk about them later. Then we draw the shared pairs as long dashes. And the last step is to verify the number of electrons should be equal to the total number of electrons we counted at the first step, and all atoms are stable by applying octet and duet rules. So let's start with our first example. We have the formula CH3F. We have to start by the first step to count the number of valence electrons after drawing the Lewis structure for all the atoms. Carbon with 4 dots, 3 hydrogens each with 1 dot, fluorine with 7 dots, so the total number of valence electrons is going to be 14. Then we place carbon at the center and the other atoms around it. We distribute the dots. First we start with the sharing dots between every 2 atoms we place a sharing pair of electrons, and then we continue placing the remaining electrons till we have 14 electrons. We make sure that carbon and fluorine are surrounded by 8 electrons each to satisfy the octet rule. Then we count the total number of electrons. Here we have 14, which is equal to the number that we counted at the first step, and the last step is to change the sharing pairs into long dashes like this. Let's have another example. Ammonia with formula NH3. The first step is to draw the Lewis structure for all the atoms. Nitrogen with 5 dots, 3 hydrogens each with 1 dot, and the total number of valence electrons is 8. Then we place the atoms, nitrogen at the center and hydrogens around it, and then we add a sharing pair of electrons between every 2 atoms. Then we continue the octet for nitrogen by having 8 electrons, and the next step is to change the shared pair into long dashes. Then we verify that all atoms are stable, nitrogen has stable octet, and all hydrogens have stable duets. Another example, methanol with formula CH3OH. The first step is to draw the Lewis structure for all the atoms to count the total number of valence electrons. Carbon, it has 4 dots, 4 hydrogens each with 1 dot, oxygen with 6 dots, so the number of valence electrons is going to be equal to 14. And to place the atoms, you should keep in mind that hydrogens should be at the ends, so the only possible way to place them is going to be like this. Then we start placing the shared pairs of electrons between every 2 atoms, and then we complete the octet for carbon and oxygen. We count the number of electrons. Here we have 14, which is equal to the total number of electrons, and then we change the shared pairs into long dashes, and the Lewis structure for methanol is going to be like this. And now guess what? It's your time to practice. I want you to pause the video, copy the formula, try to draw it, and then play the video again to check if your answer is true or not. The answer is going to be displayed directly after the countdown is over. I hope that you like this video. Please stay tuned, since in the next video we're going to talk about how to draw Lewis structure for polyatomic ions. And now you are ready to solve the end of video questions. Please, if you are not, repeat the video again. Otherwise, solve the questions, put your answer in the comment section. If you have any question that I didn't cover in the video, please share it with me in the comment section. Share this video with your friends. Subscribe to my channel to stay tuned for more videos. See you in other videos, and good luck.